Hi everyone, we are from Group 5. Today we want to discuss about our assignment. The topic is 4-bit unsigned and signed multiplier circuit. And this is the 5 member of our group. So let us carry on with our simulation explanation. So to design a 4-bit full multiplier circuit for unsigned integrals multiplication, we need to design a 4-bit full adder as shown in the figure. The 1-bit adder circuit consists of 2 XOR gate, 2 AND gates, and 1 OR gate. In the adder circuit, carry in bit C in, bit A and bit B are the 3 inputs, while the sum S and carry out are the output. C in, A and B bits will be summing, and the result is shown in the S and C out as normal output and carry output respectively. Full adder is used as there is presence of a carry in bit, so another 1-bit adder must be used since a 1-bit half adder does not take a carry in bit. So after stimulate this 1-bit adder circuit, we can get the truth table from the result. So this is the truth table of the 1-bit full adder circuit. Next, 4-bit full adder circuit is constructed to perform 4-bit binary addition. Carry in is usually 0 as the first input to the first 4-bit full adder, FA0. Meanwhile, A0 and B0 are also inputs that will be sent to FA0 to produce first sum S0 and carry out CO1. S0 is the least significant bit LSB of the 4-bit sum. Then CO will be serially sent to the successive 4-bit full adder FA1 to perform the second addition in second full adder to produce sum S1 and carry out CO2. Same operation will be repeated until the most significant bit MSB of sum SS is produced, along with the CO4, S3 and S2 are then recorded to form result with S1 and S0. So this is the input and output of the 4-bit adder shown in the figure. 4x4 unsigned binary multiplier is the combination logic circuit that can perform multiplication for two 4-bit unsigned binary number. More specifically, the two binary number can be classified to multiplicand and multiplier, and the output of the multiplication is known as product. The bit size of the product is equal to the sum of the bit size of multiplier and multiplicand. In 4x4 binary multiplier, there are 4 bits multiplier and 4 bits multiplicand. Therefore, the bit size of the product will be 4 plus 4 equal to 8 bits. Besides, in binary multiplication, there are 2 steps, which are single bitwise multiplication and adding all partial product into single product. The partial product is produced using AND gates. The number of AND gates in 4x4 multiplier can be determined by obtaining the product of multiplicand and multiplier, which is 4x4 equal to 16 AND gates as shown in the figure above. Then this is all the input and output of this 4x4 multiplier. Then the unsigned 4-bit multiplier is modified to perform both unsigned and signed binary multiplication. In this scenario, the sign magnitude form is applied where the most significant bit MSB of the inputs A3 and B3 represent the sign of the inputs. If A3 is 0, the input A is considered positive binary. If A3 is 1, the input A is considered negative binary. This has also indicated that the magnitude bits are reduced to 3, as 1 bit is used to determine the sign of binary number. Therefore, when designing this multiplier, the actual bits of input for multiplication are 3. The 3x3 multiplier circuit is then designed with 3 bits full adder and 9 AND gates to perform partial product and addition of partial product. The actual range of digital in this case is from negative 2 power of 3 to 2 power of 3. Then after we stimulate it, we get this result, and all these result we can conclude into a truth table of the negative flag and the truth table of zero flag, and also the truth table of the overflow flag. So I think that's all for us. Thank you.